All right, finally, the moment you've all been waiting for. I know you missed trig, so I was like, okay, I'll bring it back. So trig derivatives it is. Let's talk about them. All right, pretty simple to start, okay? So the derivative of sine of x is cosine of x. Weird. If you don't know why, think about the graph of sine of x and then think about its slope. It does make sense why the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x, okay? So just don't forget that negative there. That is something that people oftentimes forget. So here's our first example. We're given that y is 2 sine of x plus 3 cosine of x. So to find its derivative, it's 2 times the derivative of sine of x, which is cosine of x, plus 3 times the derivative of cosine of x, which is negative sine of x. And obviously, we want to make this look a little bit prettier, so there it is. Wonderful. Not too bad, eh? All right, so obviously it can't be that simple because then that would be boring. And we don't want math to be boring. We want it to challenge us, which it does, and which is why sometimes you guys feel stress. But that's okay as long as it's healthy stress because you're being challenged. So what the heck am I talking about? The chain rule. That has nothing to do with what I was talking about, but let's just go with it. Let's say I have the sine of something, right? It's not always going to be sine of x. Sometimes it's sine of 20,000 x squared plus e to the x. Who knows? If that happens, it's cosine of that something times the derivative of that something. Okay, so just chain rule of what's inside. So for example here, now notice that I have the product of two variables. So I'm going to have to use my product rule. The first times the derivative of the second. Well, I know that the derivative of cosine is negative sine of 3x times, chain rule, the derivative of the inside. So first times the second plus second times the derivative of the first, which is 1. And just because, you know, why would we leave something ugly like that? Here come the accents again. Perfect. Done. Oops. There's supposed to be another example, I think. There it is. All right. Oops. You don't know it was fun yet. All right. Let's have you guys try this one on your own. So go ahead, put me on pause, and then we'll check your work. Don't forget that this is sine of 6t to the 1/2 power. All right, now I'll put it on pause. Okay, here we go. So this is a double chain rule. The more chains, the better. All right. So I have, bring the exponent in front. I have 1/2 sine of 6t to the negative 1/2, reduce the exponent by 1. Multiply by the derivative of the inside. Well, the derivative of sine of 6t is cosine of 6t times the derivative of the inside again, 6. And last but not least, I multiplied 6.5. That gave me 3. Cosine of 6t stays in the numerator and square root of 6t in the denominator. All right, let's have you guys try this one. As a reminder to you, this notation means it's the sine of x, but squared. So go ahead, put me on pause, and then we'll talk about this guy. So hopefully you got one of these two answers here. So I bring the exponent in front first, reduce the exponent by 1, so technically this is sine of x to the first, times the derivative of the inside, which is cosine of x. Or maybe you're like, hey, that looks familiar. That's the double angle identity, and you rewrote it as sine of 2x. Either one of these would be totally acceptable. Yay! Yay! All right, next. Now, let's talk about these, the derivative of tangent and the derivative of secant. So we can actually find these derivatives using the derivatives of sine and cosine, the ones we already know. In fact, I feel like I've talked to some of you about this before. Well, anyways, let's talk about what this is. So we're looking for the derivative of tangent is the same as sine of x over cosine of x. Did you feel? Yeah. All right, so derivative, we got to use the quotient rule here. So it's low d high, well, what's the derivative of sine of x? Cosine of x, nice job. Minus high d low, derivative of cosine of x is negative sine of x. All over low squared. Okay. In my numerator, this is cosine squared of x plus sine squared of x. Yes, I know what you're thinking. Yes, good job. All over cosine squared of x. But then you were thinking in your brain, oh my gosh, that's just 1 over cosine squared of x. But this can be rewritten as secant squared of x. Sorry for the weird lines. That looks like a CO. It's SEC. I don't know if I can make it look prettier. Come on. All right, that looks good. All right, so that being said, the derivative of tangent of x is secant squared of x. If you ever forget that, you can always derive it on your own. How about this one? How could we derive the derivative of secant? Well, man. Every day, jeez. All right, well, that's the same thing as 1 over cosine of x, which is the same thing as cosine of x to the negative first. Okay, so let's take care of that. Let's do this derivative. Bring the exponent in front. I have cosine of x to the negative second, but don't forget to multiply by the derivative of the inside, which is negative sine of x. Interesting. Well, this here is going to be, well, the negative 1 times the negative over here is going to be positive. I get sine of x over cosine squared of x. Well, that's sine of x over cosine of x times 1 over cosine of x. So notice that all I did was separate that cosine squared into 2 cosines. Well, this is tangent of x times secant of x. Oh, come on. So, voila, the derivative of secant of x is tangent of x, secant of x. And do you notice that both of these, the derivative of tangent of x, oops, that's not it. The derivative of tangent of x was secant squared of x, and notice that the derivative of secant of x was tangent of x, secant of x. Interesting. Now, keep in mind, same as always, if there is something more than just x in there, like, you know, something crazy, don't forget to multiply by the derivative of the inside, which is the chain rule. So let's take a look at our first derivative. Well, we know that the derivative of tangent of x is secant squared of x. So its derivative for tangent of x squared is going to be secant squared of what's inside, which is x squared. But don't forget to multiply by the derivative of the inside. This is my chain rule, 2x. Done. Okay, so we're almost there, guys. Hang on tight. Don't fall off the ship yet. All right, so, I just dropped the pen. Forgive me. Obviously, we have more trig functions than just those 4. So the derivative of cosecant of x, we could derive all of these in the same way, like breaking things down into sine and cosine, just knowing those. But I'm going to save you guys the time. You're welcome. The derivative of cosecant of x is negative cosecant of x times cotangent of x. Chain rule. And the derivative of cotangent of x is negative cosecant squared of x. Now, just a little helpful tip someone once told me is that the derivatives of any of our trig functions that start with the letter C always have a negative in front. No, it's not because it starts with the C. There are different reasons, but that might be helpful for you in terms of knowing when it's positive or when it's negative. So like sine, tangent, secant, those are all positive derivatives. And then cosecant, cosine, and what am I missing? Cotangent are all negative. Neat. All right, so let's practice here. Find the first derivative. So I'm going to have you guys try this one, but note that this is a product rule and this is a product rule. Go ahead and put me on pause. so don't forget, we said that we were going to use our product rule here and our product rule here. I want that to be a different color. So why don't you listen to me, computer? All right, very good. So for this first part, here's where we see, oh my God, like, doesn't it know what I'm thinking? Just do what I'm thinking. Jeez. Okay, so this is the first times root of the second plus the second times root of the first. The second part here, see what I'm dealing with, guys? Same idea here. This is the first times root of the second plus the second times root of the first. All right, excellent. In conclusion, trig will never die. It's here to stay for life. Yes, for life. Okay? If you know the derivative, sine, and cosine, you can figure out all the other ones. That's how smart you are. Great job.